Hello everyone, this is Manish from Skillable India, and in today's session of geometric dimensioning and tolerancing, we are going to understand the very important GD&T geometric symbol or the geometric tolerance, which is about the straightness. Okay, so straightness tolerance basically comes under the form type. Okay, so it basically controls the form of the part. Okay, so in straightness tolerance, first we will understand the help of a definition. So the symbol of the straightness tolerance will be like this. So whenever there is a straight line, okay, we are using in the first compartment of the feature control frame, then it is a symbol of straightness. Okay. So straightness is a two-dimensional GD&T column. So first of all, whenever we are using straightness tolerance, so it is a two-dimensional GD&T callout that controls the straightness of the part feature. Okay. In this case, you can see this is a part, and this part, this surface is having arrow line. Sorry, this having line arrow line. Okay. So it's a feature control frame. So in this feature control frame, it is a this feature control frame is arrowing towards the surface. Okay, so surface is considered to be a part feature. Okay, so this is how we provide the geometric tolerance straightness to a part feature. Okay, whenever we are putting arrow towards the surface or towards whole surface or any other surface, so we are providing the straightness tolerance to a part feature. No axis can be perfectly straight. Okay. So here no axis can be perfectly straight. Let's say if there is a round part. Okay. If the part is having in a round profile. Okay. Like this, we will understand further with the example. Okay. So the axis at the center of this cylindrical part is not cannot be perfectly straight. Okay. So to control this axis straightness, we give the feature straightness tolerance to a feature of size. So basically, we will discuss this thing. So the goal is to ensure it is straight enough for the application. Okay, we already know that anything which is manufactured by the machine cannot be perfectly in the shape. Okay. So control this that its application do not hurdle or the axis of the shaft or the pin should be enough straight that its assembly or the application we can ensure. Okay, so this call out set a standard on how straight a feature must be along its length. Okay, so along its length, we are talking about if we are talking about axis, so we are talking about the whole length of the part till the axis is there. Okay, so if we are talking about this part, so we are talking about the whole length of this part. Okay, so this is very important. Straightness can control two very different types of function. Okay, straightness can control two different type of function. It is the only call out that can control either the line or a surface or a feature of size. Okay. So what does this mean? First of all, straightness can be provided to a feature. In this case, this is the first case. Okay. So this is the case first when the straightness is a straightness symbol is applied to a feature. To a feature. Whenever you can see over here also straightness tolerance applied to a feature. Okay. So whenever the leader line is pointing towards the surface, so it means that we are providing tolerance to a feature. Okay. In this case, this is the second example. So the straightness applied to a feature of size or axis. Okay. So whenever, let's say here we are using the word dia. Okay. So whenever we are applying the tolerance, straightness tolerance to a axis. Okay. So in this case, this red line over here is the axis. If we are providing this and the leader line, in this case, leader line will be perpendicular or parallel with the dimension. Okay. So whenever we provide the straightness tolerance to a feature of size, we will show the tolerance feature control frame with the dimensions. Okay, and whenever we apply the straightness tolerance to a feature, we will pointing towards the surface, towards that feature for which we are providing the straightness tolerance. Okay, now in the feature of size, whenever we provide the straightness to a feature of size, we can use the maximum material condition and the least material condition, because we cannot apply maximum material condition and least material condition to the feature, but we cannot apply onto the feature, but whenever there is a feature of size, to the material condition modifier we can provide. So in this case, we can provide the maximum material condition or least material condition to the part. Okay. So in the next example, we will understand with the same example that how we can do this. Let's say, so first of all, first we will understand straightness applied to a feature surface. Okay. So when we apply the straightness tolerance to a feature, when we apply this call out to specify the surface straightness, the tolerance zone forms a total white zone above and below the ideal surface position and controls any deviation. Surface straightness controls the form of a line anywhere on the surface, and the has two type of applications. The first type, it is a flat surface such as a face of a cube. Okay, and in this case, this is a cube. Okay, so this surface straightness, if we are seeing from the right side, this the flat surface. Okay, so the straightness can be at single line. Okay, straightness can be a single line at any point. Okay, so it can be a straight line. So if we first type, if we understand, so in a detailed manner. Okay, so let's say I am taking an example over here. This is a part. Okay, and this part we have provided the size dimension, which is of 50 plus minus 0.1. Okay, so when this part is manufactured, after manufacturing this part, we can have the axis, let's say, like this. Okay, so and we take the height between the peak and valley. Okay, so if we take the peak and valley, so this is the peak, which is the maximum we can allowable deviation can have, and this is the valley, which is the minimum. Okay, so in this case, this distance we can have plus minus 0.1, so here we can have the deviation of 0.2 mm over here. Okay, so the difference cannot be more than 0.2 in this case, which is the size tolerance. Okay, so this is what rule 1 tells. The rule 1 tells that we should be within the tolerance zone. Okay, so now if you want straightness control, then what we achieved from rule 1, then I have to use the straightness tolerance over here. Okay, so if I use the straightness tolerance, so after applying straightness tolerance to a feature, okay, so because we are talking about the feature, so can be applied in two ways: applied to onto a surface and applied onto a axis. Okay, so first we will discuss how to apply straightness onto a surface, and we will go to then we will understand about the axis control. So first of all, if you want to control the straightness of a surface, then what we have to do? Then the leader length should point towards the like this. Leader length will follow straightness and 0.1. Okay, so this is how we can apply the feature control frame onto the space. So what we want to control and probe leader line with the feature control frame. Okay. Now what we are having over here, in what the cases we are making. 1 second, I will let you know. After applying the feature control frame. Okay. So the geometric tolerance value should not be less than the tolerance. Whenever we are applying any geometric tolerance value, it should be not less than the tolerance value, size dimension. Okay, so here the size tolerance is 0.2. So here we are using 0.1 as the geometric tolerance. Okay, so now what we have, Okay. So from here to here, we have size dimension of 50.1. Okay. And from here to here, we have the size dimension. What we have is 49.9. Okay. Now, this is 0.2 mm of tolerance. Now, anywhere between this. Okay. So it can have like this, anywhere in between. But the thing is that the peak and valley of this profile of after manufacturing. So this is the case of after manufacturing. This is never be more than geometric tolerance. It should be within the 0.2 mm of tolerance, and it should be always, I will say, 0.1 mm. Okay, it can be like this in a straight line, or the situation can become that it cannot be straight line. Let's say it can be like this also in a taper line. Okay, but if we are providing the straightness to a uh, feature, okay, in this case also it will be mentioning that the peak and valley should be within the tolerance zone. So this peak and valley should not be more than 0.1, although it will be within the 0.2 mm of tolerance zone. Okay, 0.2 mm tolerance. If it is in a taper shape, it will be acceptable. Okay. So where the maximum limit of is this 0.2 and the geometric tolerance is 0.1. If the part is manufactured in a taper shape profile, so it will be always in the within the tolerance zone as per the rule 1. Okay. So here you may have the end up with the taper with the minimum size of the 49.9 and maximum size of the 50.1, which is allowed. But the surface peaks and valley, the high points and the low point should not be more than 0.1. So this is the straightness control onto the surface. Okay. Straightness control onto the surface is a two-dimensional entity. I have already told you. And tolerance zone is two parallel lines. Okay. So whenever we are talking about the tolerance zone, whatever tolerance zone like this, if we are it is always a two parallel lines. Okay, so this is how they are controlling the 0.1 over here. If we are not understanding, so it is in a taper shape, but it will always be in a rule 1, always act. Okay, so rule 1 always says that we can the part should enter into the actual mating envelope. Okay, so envelope is the maximum limit MMC condition, which is the maximum material condition of the part. Okay, since we are applying straightness onto a surface, it is a feature control, and we will not be able to apply the MMC condition. So whenever we are applying feature straightness tolerance to a feature, so we are not able to apply the MMC or and LMC condition. Okay, now we will see. Now I will remove this. Okay. Now what we will see in the next example, we will apply the straightness tolerance to a we will apply now we'll to the straightness of the axis of the shaft. Okay, so now we will apply the straightness of the axis of the shaft. In this case, this is the leader line. It is showing to the this the part axis. Okay, to control the straightness, to have the in the second part. Okay, so straightness applied to a feature of size. In this case, we are applying the to the axis. Okay, straightness tolerance to the axis. Since you can see this that in this case where we have provided the tolerance, we have provided in this example to the feature of size. Okay, so this is in 2D shape. We have provided the to all the length, okay, of the part. We have provided the straightness tolerance to the feature of size on the axis of the shaft must be within the cylindrical of the dia 0.1. Okay, so here we have used the diameter 0.01. So this diameter Okay, so here we have 0.1. Okay, so if we remove this 0 from here, okay, so this 0 is removed. Only 0.1 at maximum material condition is there. So we have the 50 plus minus 0.1. So the maximum we have is maximum shift we have 0.2 mm. Okay, and the minimum shift we can have is of 0.1 mm within the cylinder. Okay, so in this case also, if the after the manufacturing this part, so we have 0.2 mm of tolerance zone, but after manufacturing the part can be end up like this. Okay, its axis is tilted. Okay, so it should be within the tolerance zone. So what we will do over here is that it should be within the tolerance zone. So we will make two straight lines to form this axis in the tolerance zone. Okay, I will rub this because it is not proper. If we will see this in a two parallel planes, okay, parallel lines we will provide. So now we have give the straightness to the axis. Okay, so in this case we have provided the tolerance zone. In when we apply the straightness tolerance to a feature of size, we can apply the maximum material condition and minimum material condition. Okay, so we will give the call out over here as the feature of the size controlled, and then get the three-dimensional entity. Okay, so in this case you will see that this cylinder of tolerance zone. So this is a cylindrical cylindrical tolerance zone. Okay, so this is a cylindrical tolerance zone over here, and this is a three-dimensional entity. Whenever we apply the straightness to a feature of size, then we can apply the MMC and the LMC conditions. So here in the example, I have given the maximum material condition modifier, which tells that whenever the shaft is at the maximum material condition, okay. So if the shaft is manufactured at 50.1, okay. So this shaft is manufactured. What will be the MMC condition? MMC condition for this shaft will be 50.1 and LMC condition will be 49.9. Okay. So when the shaft is manufactured at 50.1, the tolerance zone will be 0.1. Okay. So whenever shaft is manufactured at 50.1, which is MMC, so the tolerance zone will be 0.1. When we move from MMC towards LMC, okay, let's say when it will be 50, we have 0.2, and when we have 40.9, we have 0.3 mm of tolerance. Okay, so as we move from MMC towards LMC, we get more tolerance zone. Okay, so the worst case possibility to manufacture the shaft is at LMC, which is 49.9. When it produced at 49.9, then the geometric tolerance will be 0.3 mm. Okay, we get increase in the tolerance zone. This is about the straightness tolerance. Okay, so whenever we apply the straightness tolerance to a feature of size, we can apply the maximum material condition and the minimum material condition modifier, and this is how we can get the more tolerance with the help of this condition modifier. Okay, so after manufacturing we can have like this. Okay, so whenever this axis always be within the tolerance zone. Okay, within the this cylindrical tolerance zone, this axis should be always be within this. So this is all about the straightness tolerance. Okay, so if I summarize the whole session, so straightness can be applied two ways. Straightness can be applied to a feature which is considered to be a surface, and straightness can be applied to a feature of size which is the axis. Okay, so whenever we apply to a feature, we cannot use the material condition modifier or the MMC condition or the LMC condition. But when we apply to a straightness tolerance to a feature of size, which is the X, we can use the maximum material condition and least material condition. modifier. So this is all about the straightness tolerance. Thank you all.